So once the business requirements document has been completed, then someone, usually other than the business analyst, although many organizations, people wear many different hats at different times, but that business requirements document has to then be expanded to become the solution design. Now, bear in mind that these solution designs, or functional specs that some people call them, or technology architecture, this doesn't need to be done if your business requirements document is going to be issued to a vendor as an RFP, as an example. But if it is going to be done prior to sending it out to a consulting firm or to a programming house, or if it's going to all be done in-house, then it's got to be expanded to address the solution, to look at how the business requirements are going to actually be implemented. So we do that by adding details to each of the business process diagrams. And we convert the business rules table ultimately into a logical data model. Now, it's not just a table that gets converted into a logical data model. It's, of course, the object definitions of data attributes and everything else that goes with that. And we have to add a whole bunch of other things in terms of the solution design. There's a lot of work that goes into this. This is when somebody has to spend a lot of time figuring out the best way of actually delivering the business requirements. Now, one of the essential issues in the solution design, of course, is the database design. And the first step in the database design is to produce a logical data model. What we did, and I'm going to bring you over here again once more, is we identified the objects, we identified the data that's essential to the business, and we created a table. And this table, when we created it, was to identify the business rules. But it's really a lookup table as well. You know, we can ask questions about this table in a different way. For example, if I know the customer, if I know who the customer is, can I find the payments that that customer has made? And this cell tells us that, yes, we can find those payments. There's a requirement to join the customer record with all the payments records. There could be one payment record for that customer, could be several payment records, or it's possible that there is no payment record at all. And in this case, we're talking about none at this point when we're looking at solution design. So this table tells us that regardless of how the database is designed, we have to be able to find the payment records for an individual customer. We also have to be able to find the outlets that they may have shopped in. So this becomes, in effect, a data model that says these are the things we have to be able to retrieve. And part of that comes from, or is used then as a guide in creating the logical data model. So where does it come from? It comes from, first of all, the business rules table. That business rules table can then be translated or converted into different forms of diagrams by the database designers. Now, obviously, they're going to be object definitions and data attributes as well. But this table can turn into a Chen type ER diagram or entity relationship diagram. And this kind of diagram here is exactly the same as this kind here with the crow's foot notation. Now, nothing wrong with the crow's foot notation if it's kept behind closed doors, if it's kept away from the clients and subject matter experts. You know, they can understand quite easily ones and ends and zeros. You know, ones and ends and zeros are used in every language and every culture. These crow's feet, which are easy to learn, however, are not as intuitively obvious for people. But it's the same thing. This translates very, very nicely. So the other element in database design is, of course, keys and foreign keys. Remember that we talked about unique identifiers. And unique identifiers are keys. Now the database designers have to start looking at the composition of these keys that we've already stated earlier in the business analysis. And the foreign keys were the pointers to related objects. Where do they come from? Once again, in our business rules table, excuse me, these entries, or cardinality as they're called, that we've stated, translate into foreign keys. Here, we're in effect saying, let me go around this side here. Here, in effect, we're saying the object customer has to have its own unique identifier, of course, but customer also has to be able to join with the object product. And product, there may be several records. There's an N in there, meaning numerous or several. Therefore, we state the foreign key for a product. And from a business analysis perspective, all we do is say product ID. We don't worry about the composition or the technical name. So here we have product ID. We also have outlet ID as well. And the MV behind it means it's multi-valued. Whenever there's an N in here, we put the MV behind it, meaning there could be several. So that information is now available to the database designers. And we've done that through the business analysis without getting technically involved with the client. So there are 6 basic steps in expanding the business requirements into system requirements. Now, depending on the project, obviously there could be more and sometimes less. There could be more steps. So at a high level, however, the first step is to identify interface requirements. That is, an interface requirement is a person, a machine, or another computer. So here we have a process to pay a supplier. And you'll see here, we have the payment data flow going from the process to this terminator called supplier. Here we have supplier information, and we keep track of the supplier payment. Well, as soon as there's a data flow that's between a process and a terminator, then that has to be an interface of some kind. The only question is what kind. This payment, for example, that goes to a supplier, how many different ways might we make a payment? Obviously, you can cut a check and send it to them through snail mail. You can make electronic payments. There's several different ways of making electronic payments as well. The likelihood is, in terms of architecture, that with a supplier, you're actually going to pay them more than, you're going to have the ability to pay in more than one way because of the many different suppliers that you might have. The other thing that we need to do is to identify, and cross over here, software tasks. Now, this used to be called functional decomposition. Some people still call it that. But within each process, remember we said that a process consists of a number of subtasks. So a number of tasks equals a process. You remember that when we wrote the narrative for a process, we enumerated them, and each one of these became a task. Well, a task is either going to be automated, or it's going to be not automated, or it could even be an interface between the two. So this narrative then, list of tasks, in other words, becomes the foundation for the designers. And they have to do some work in terms of building that interface. And designers may then want to expand this model using other methods and other techniques at this point. You know, it could be swim lanes, for example, or at this point, UML becomes very, very useful. That's not useful for business analysis. I know that some people would disagree with me on that, but nonetheless, they're allowed to be wrong. I believe that UML is best used. It's a wonderful suite of tools, if you like, that's best used when we're working on the decomposition and the solution of processes. That's a good time for them to do that. But the information is ready for them to work with. So it helps to keep the designers very well focused. The next step is to identify the data that's required for each of these tasks. You remember the tasks we identified. The designers are going to work with those to perhaps expand them, perhaps collapse them. But there's data that's needed for each of those. We've already done the essential work on that in analysis, not the detailed work. The designers get to do that, lucky for them. But we've done the essential work. We have the objects here, supplier and product shipment, purchase order, payment, and so forth. And we've said that for a task from a higher business perspective, that we need this information. We need supplier payment information. We need, for this task here, we need product shipment information, shipments received, and so forth. Well, what they're going to do is they're going to say, well, we don't necessarily need all of the product shipment information to deal with this task. We need a subset of this information to deal with that task. And they'll get into the nitty-gritty of identifying the data for the individual tasks and subtasks that they create in the solution design. They also have to identify the data accesses. Well, you'll remember the business rules table. And the business rules table really says these are the required data accesses. Now, from a business perspective, we're really saying, look, we don't care how you get there, but this is absolutely required. From a business perspective, if we know the supplier, we must be able to find the payments that we make to that supplier. And we might make one payment, several payments, or we might never make any payments at all. But those are the rules for supplier. How does a database designer get there with that? We don't care. It's just like inside the television room. We don't really care how it works as long as we get the picture that we want. So we have the essential information for each process, and they can expand that information to be able to develop a solution design. The other thing is that we need to write test cases, and those test cases must be based on the business rules, at least from the perspective of functionality. And the first step in a test case is determine the functionality. Where's the functionality? It comes from the business rules that came from the business rules tables for each of the processes. And test cases then become very, very straightforward to be able to create. These are not test cases relating to how things are done, but just pure functionality. And the sixth item is, then we're pretty well ready to build the code. Now, it depends on the project, admittedly, it depends on the complexity or the simplicity of the project. But when we build the code, Bob's your uncle.